Hello again, everybody. Our lecture today is air considered to be matter? Now, this can be a little bit of a tricky problem because air, you can't really see it, usually can't really smell it, so it might be hard to know if it is matter or not. The way we're going to look at it today is we're going to think about our definition of matter. So if you remember, what is the definition of matter that we've been using? Well, the definition of matter is that anything that has mass and anything that has volume is going to be considered matter. So let's think about that. Matter has mass, it's made out of particles. So if air has particles, then we might think that air is mass. And a good way to think about if air has particles or not, if you just take your hand and you wave it real fast back and forth, you can actually feel the air molecules hitting your hand. So that can give you a clue that air is made of particles and therefore air is mass. And another thing is to think about if something has volume. That's the same as thinking about if it takes up space or not. So does air take up space? Well, and a good way to check to see if air takes up space is to do something like this. Take a balloon and you have a deflated balloon. Doesn't take up very much space. You blow up the balloon, it gets bigger and bigger and bigger. So that air is pushing the balloon out. The air is taking up space. It has volume that's filling up space inside that balloon. You can do that again with a deflated soccer ball. The deflated soccer ball takes up less space than the inflated soccer ball. Here's a demonstration that we'll do in class. Maybe we'll get a video of it and post it. So now we've showed that air has volume, that air occupies space. What else do we need to show to prove that air has matter? We want to show that air has mass, that air has weight. And this is really kind of hard to do. So, you can take a deflated balloon and put it on a balance and then blow it up, and you'll see that the weight is different. But that's not real good because you're changing another variable. You're changing like the size of the balloon. You want to keep everything as similar as possible. So when you're doing an experiment, so let's think about this. Like, let's say we have a helium tank for blown up helium balloons for a birthday. You may be able to buy these at Walmart, things like that. Helium is a gas. Helium can be found in our atmosphere, just not very much of it. We need to show that helium has mass, that helium has weight. And that might even be kind of tricky to think about because if you have a helium, you fill up a balloon with helium, the balloon will actually float. So we do want to see that helium has mass. So what we should do is we should go ahead and get the tank, and then what we're going to do is we're going to take the weight of the tank itself. When the tank is full, it weighs 22 pounds. And when we open it up and release all the helium, after that's all gone, then we weigh the helium tank again, the empty helium tank, and we see that the helium tank, when it's empty, is only 18 pounds. So the weight of the tank decreased when we released the helium. The helium compressed in the tank had a mass of 4 pounds. That's the difference. Let's take a look at these clips. The key to understanding this is the compressed part. What we're going to do is we're going to stuff the tank filled with helium. We're going to stuff a bunch of helium, as much helium as we can, into that tank and just keep stuffing it in. So what does helium look like? Well, if we take a look at helium on a molecular level, it's going to look something like this. This is an atom of helium. It's the second smallest atom. The only thing smaller than helium would be hydrogen. Helium generally is going to have 2 protons and 2 neutrons and 2 electrons. Very, very small particle. And let's just imagine that we can put these particles of helium in this helium tank. So what we're going to do is we're going to put 1 atom of helium in the helium tank, and it's floating around. It's got plenty of space. So what we're going to do now is we're going to add another one. And you can see now it's a little bit more crowded. So we're going to keep putting more and more helium particles in the container. This is going to be pressurized. We're going to shove a whole bunch of more helium in this little container than it normally should have in this amount of space. And it gets more and more helium, more and more crowded. And these particles are going to have mass. So we're going to keep adding more and more particles. And we keep stuffing in these helium particles until it can't hold any more without bursting like a pop balloon. So now this helium tank is completely full. It's pressurized. There's a lot of helium in there. So if we open up this valve, the pressurized helium is going to rush out the valve. That's why the helium gas shoots out of the valve like this. It's pressurized. It's high pressure inside, low pressure outside. Each one of these little particles has mass. They're physical stuff. We can weigh this now. We can measure this now. So if we take the mass of the empty tank and then we take the mass of the full tank is going to weigh more than the empty tank. And so what's our conclusion? Well, there's three things. Air is matter because air is made out of particles, air takes up space, and air has mass. And a good way to remember this is to take a look at the All This Stuff Is Matter song. It's based on the Lego song, All This Stuff Is Awesome. And it talks about all this stuff is matter. Matter has particles, volume, and mass. All this stuff is matter. Matter has particles, volume, and mass. All this stuff is matter. Solid, liquid, and gas. Now let's do a real quick review of what we've learned. First of all, the definition of mass is, and what I'm going to do is I'm going to pause for a second. You can pause the video and answer it on your own, and then just continue when you're ready to go. So what is the definition of mass? Mass is the amount of mass or the amount of particles in an object. The more matter in an object, the greater the object's mass. And here on Earth, gravity is going to pull on that object's mass, and that would be what we would call its weight here on Earth. The definition of volume is the amount of space an object occupies. Describe a way to show that air has volume. How can we show that air has volume? To show that air has volume, you need to show that air takes up space. An easy way to do that is to add air to a balloon, and the balloon gets bigger. It increases the amount of space as you blow up that balloon. So you have the empty balloon, you blow it up, you add air to it, and as you add more and more air to it, the balloon is going to take up more and more space. It's going to increase in its volume. And a way to show that air has mass, a good way to show that air has mass is to either add or subtract air from a container. Especially a fixed container is a good idea. Instead of using a balloon, which can change volume, you want to keep just one variable changing as possible. So if we used a fixed container like a can of compressed air, we can weigh the can of compressed air and then release some of the air, and we'll see that the can of compressed air will actually get lighter as you release some of that gas. If we wanted to list three reasons that helium gas would be considered to be matter, well, we would remember what are the characteristics of matter. Matter is going to be made up of particles, so therefore helium must be made up of particles. Helium has volume, it has to take up space. And helium should have mass. Okay, well that's it everybody. Have a great evening, and we'll see you next time. Bye.